Many concepts in fundamental physics and engineering depend on the existence of what we call imaginary numbers. Imaginary numbers have important practical consequences for our everyday lives, and they are key to understanding the philosophical implications of quantum mechanics. Imaginary numbers are used in Schrödinger's equation, and they are used in fields such as stability analysis, AC current analysis, and many others. Yet these are numbers that are impossible to see or touch. The only numbers that we can physically see and touch are positive real numbers, which are represented by this number line. But there also exists another very useful set of numbers called negative real numbers, which are represented by this other number line. In addition to positive and negative numbers, there exists yet another set of mysterious numbers which are just as real, even though we have chosen not to refer to them as real. Instead, we have decided to refer to these numbers as imaginary, and these are represented by these two new number lines. A number can appear anywhere along any of these four number lines. A number can also appear anywhere in the plane formed by these number lines, in which case the number is the sum of a real number and an imaginary number. The set of all the numbers that can appear in this plane are what we refer to as complex numbers. We can represent each complex number as an arrow, as shown. When two complex numbers are added together, their arrows add together like vectors to produce the result. This means that their real portions will add together, and their imaginary portions will add together. A complex number can be represented by its real component and its imaginary component. Or, the complex number can instead be represented by the length of its arrow, and the angle that this arrow makes with the positive real axis in the counterclockwise direction. Suppose we have two complex numbers, represented by these two arrows, and we multiply them together. Their product will be represented by a new arrow. The length of the new arrow is the product of the length of the two original arrows. And the angle of this new arrow is the sum of the angles of the two original arrows. The length of the new arrow is the product of the length of the two original arrows. And the angle of this new arrow is the sum of the angles of the two original arrows. Suppose that we have a number that is represented by an arrow with a length of 1 and an angle of 90 degrees. We will refer to this number as I. If we multiply I by itself, the product will be represented by an arrow. This arrow will have a length of 1 multiplied by 1. And it will have an angle of 90 degrees plus 90 degrees. Therefore, the new arrow will have a length of 1 and an angle of 180 degrees. This number is -1. Therefore, I multiplied by I is exactly equal to -1. We can represent this by saying that I squared is equal to -1. Or we can represent this by saying that the square root of -1 is equal to I.